Alright, today's lesson's on solving absolute value equations. An absolute value equation has a possibility of two solutions. This is because the value inside the bars, or inside the absolute value symbols, can equal either the negative or the positive of the value on the other side of the equal sign. Always isolate the absolute value expression on one side of the equal sign before breaking the problem into two pieces. Always check your answers to make sure they work in absolute value. Step one would be isolate the absolute value. There are two cases because the absolute value can be the positive or negative, so set up two possible cases, then solve. Third step is check. Alright, so let's look at an example here. First thing I'm going to do is make my two cases. Case 1. All we need to do is to drop the bars and rewrite the problem. Okay. Case 2. Not as simple. We drop the bars on the left, but on the right-hand side, we need to multiply the whole right-hand side by -1. Now we just solve like we have been. Subtract 15 on both sides. -3x equals -9. If we divide by -3 on both sides, x equals +3. And go to case 2. We need to multiply -1 times 6 first. Now we're going to subtract 15 on both sides. -3x equals -21. Divide by -3 on both sides. And this time I get x equals +7. We got to do our third step, check. How do we check? We need to take the two answers we got, the two solutions we got, and substitute for x. 15 subtract 3 times 3. 6. So we have the absolute value of 6. The absolute value of 6, since we have a positive number, is just 6. Now we're going to check case 2, our second solution. (15) subtract 3 times 7. -6. Absolute value of -6. Remember that since it's negative, we take the opposite of -6, which is +6. And both solutions work. Okay, now we need to write the solutions together in squiggly brackets. So this is the solution set of 3 and 7. Okay, let's look at example 2. Okay, this one's a little bit different. Why? Because the absolute value here is not isolated. So the first thing we need to do is isolate the absolute value. So that means get rid of the -3. Remember back to the slide before, step 1 was isolate the absolute value. So how do we get rid of that -3? We add 3 to both sides. And we're left with absolute value of y plus 4. isolated. So the next step would be make your two cases. Remember case 1, all we do is drop the absolute value bars and rewrite. Case 2, drop the bars, multiply the other side by -1. Now we need to solve. Subtract 4 on both sides. And y equals -1. Multiply -1 times 3. Get -3. Now we subtract 4 on both sides. Y equals -7. So I think I have two answers. I need to, what next? Check. How do I check? Take -1 and substitute it back in for y. And we want to go all the way back up to our original problem. -1 plus 4 is negative or positive 3. So we have absolute value of positive 3, subtract 3. Absolute value of 3 is 3. 3 minus 3 is 0. We have a true statement. So the first solution works. Now we need to check the second solution. So you can substitute -7 for y. -7 plus 4, -3. Absolute value of a negative number. Remember, we take the opposite of the negative number. Opposite of -3 is positive 3. 3 minus 3 is 0. We have a true statement. So the second solution works. Now we need to rewrite it in our solution set. -1, -7. Example 3. Does example 3 look like example 2? Yes, it does. Okay, so first step would be what? Isolate the absolute value. Here we do that by subtracting 6 on both sides. We have the absolute value of 3d minus 9 equals -6. I have the absolute value isolated. We know that absolute value always has to be positive. Here I'm saying that the absolute value would be what? -6. Is that possible? No, it's not. Absolute value can never be positive, so I can stop this problem right here and say that the solution is an empty set. So I draw my brackets and I leave it empty. This is the empty set. Extraneous solutions.